This is KBYP approaching the topic of the mythical ferrite clamp choke on the outside of the coax that prevents common mode currents from flowing down the outside of the coax. My, doesn't that sound impressive? That's 15 buzzwords strung together, and every one of them is false. The idea behind this is that noise heard in the receiver, which is due to a badly mismatched antenna system, and I've proven that in another video, that somehow that noise is due to RF currents coming down the outside of the shield of the concentric coax, and that putting a ferrite clamp, which is a choke, at the top of the line at the antenna will somehow stop those currents from flowing down the outside of the shield and making noise in the receiver. That is entirely myth. It violates the laws of physics, and I'm going to explain what is really happening, or actually what isn't happening. A choke in the world of electricity is an inductor. An inductor, a coil of wire with many turns, usually around some kind of magnetic core to increase the inductance, where the choke is essentially an open circuit to RF. If we want to choke something, if we choke a cold automobile engine, we cut the airflow off so that there's very little airflow and more fuel for starting, because the fuel is cold and it condenses and drips and puddles in the manifold and doesn't vaporize well. A choke is intended to allow no RF current to flow. Chokes are usually a very large value, as large as practical for construction and fitting space-wise, but particularly to not have self-resonances at whatever frequency is supposed to be choking. A choke is an inductor. By the laws of physics, an inductor receives a current and generates a magnetic field, and in reverse, that magnetic field returns to the circuit as a current. An inductor, a choke, do nothing with the energy themselves. They store it and return it. They are conservative. The energy doesn't go anywhere. It's still there. For example, a 50 ohm inductive reactance of an inductor at 7 megahertz, by the calculation, X of L equals 50 ohms over 2 pi times 7 times 10 to the 6th cycles, is 1.14 microhenry. In engineering, we often use a times 10 multiplier. But let's just say we want a 500 ohm choke, which is a huge inductance. For a 50 ohm circuit, a 500 ohm choke is basically an open circuit. That calculates to be 219 microhenry. That's a lot of inductance. The inductor opposes the flow of RF current by this conversion from current to field and back and forth. It does not destroy the energy. When we talk about these clamps, and here is one of them. This is a special one made by Laird. What these things are essentially toroid cores. They're split toroids. And there's the split. It's a split toroid core conveniently snapped together over basically a wire going through it. This is not ordinary ferrite material. This is a layered snap-on ferrite intended for HF suppression. This does not make an inductor. It does not store and return the field energy. It destroys it as heat. This is special ferrite material. It's not an ordinary core that we make an inductor with. We can't make inductors with this. They don't work. What that does is effectively destroys the energy. It doesn't store it and return it. For these to be worth the powder it takes to blow them up, if you look at tables for these kinds of things, we see that with one pass of wire through, there's essentially no inductance if it were that kind of ferrite. What's necessary is to pass several turns of wire. If we remember the inductor formula, N is a big deal. Number of turns in an inductor, see the symbol there? It implies a number of turns. more inductance. So, ferrite clamps are not chokes. So the meme of I put a ferrite clamp as a choke is false immediately. Completely false. There's no choking going on. In order to be a choke, there must be inductance, and there's essentially no inductance. So back to our mythical clamp, generally put near the antenna. That's not a choke. The idea is that RF energy is intercepted by the shield and causes current to flow down outside the shield. There is no such thing in electrical physics. That violates the laws of physics. The shield is made of individual stranded wires usually. Under the law of skin effect, RF current flows near the surface of the wire, but it flows all the way around the wire. There's no such thing as current flowing on the outside of that shield as a unit, as an assembly. The current flows down the entire shield, inside, outside, upside down. What is outside are the probably magnetic fields that are intercepted by the shield. As I showed in a previous video about what happens when transmission lines are not properly terminated, that shield is called a shield because when a line is terminated with the characteristic of 50 at each end, the line, if the shield is completely solid and impermeable, and most of them aren't, but when the line's properly terminated on both ends, the shield keeps outside fields from reaching the center conductor. Now hold that thought for a second. Let's look at this thing about the current going down the shield. If the problem is receive noise due to these currents that are going down this shield, understand that this is an unbalanced or single-ended line going to an unbalanced or single-ended receiver in most cases. Some of the old rigs might not be. If you got a receiver from the 40s, it might not be. But all our modern rigs are SO239 unbalanced coaxial connectors. The receiver does not listen to the shield. The receiver listens to the center conductor. Therefore, it is illogical to say that the receiver hears RF currents going down the shield. They're going to ground where they're not heard, so to speak. In the previous video, I showed a university source that shows that when the line is not properly terminated, then the fields can go through it and deposit currents on the center conductor, and the receiver is listening to that. As a proof, I'll show you a proof, a very simple proof. And while you're watching this upcoming proof, realize that if this really is a choke, and it is not, and the goal is to intercept currents coming down this 50 to 200 feet of line to the receiver, then it's inherently wrong to put the so-called choke here. If we want to stop it from going to the receiver, we would put it here. The next thing we would not do is that we would not, under any circumstance, ground that line. Guess what? The earth is noisy. That shield grounded just formed a vertical antenna that's not tuned and not receiving on the desired frequency. It's a natural pickup for noise. Get rid of the ground. I've shown you this experiment before. 40 meters, close-in propagation. The noise distribution peaks on HF at 8 megahertz from basically 1 to 10. It's predominantly lightning discharge noise, lots of little discharges. But we're hearing the noise in the receiver. And notice it's pretty much a steady S3. There's the 40 meter antenna. See the 40, coaxial jumper here. Now, let's disconnect the shield. I'm going to disconnect that. And you'll know immediately when I pull it loose, because the noise goes through the roof. That's because the shield on this end is now broken. See the gap? There's no current flowing down that shield into the receiver. It's not connected. The shielding effect of the shield has been lost, and this is now a big noise antenna. When the properly matched antenna at 50 ohms into a 50 ohm line is sending a signal down and sees an open circuited transmission line, the energy is reflected. So the only thing left to speak of is this long center conductor that is no longer shielded. And this is 130 some foot of transmission line. It's a huge noise antenna. Another 3S units, which is what, 20 dB? And this is exactly where the noise is coming from that you think is going to be fixed by a ferrite clamp. Now, what did I just do? Oops, I just reconnected the shield. And this is how all my antennas are, especially my vertical. Except for very noisy band conditions, they pick up no local noise. They're dead quiet because the transmission lines are perfectly matched. And the shields are really shields. When the transmission line is not properly terminated, such as the extreme case here with the shield completely open, two things happen. Number one, energy is not transferred from the antenna into the receiver. The received signal coming in goes down, the AGC goes up to try to level the signal off. So the AGC increases sensitivity of the receiver. And that is what leads to that tremendous increase in noise. Because now the signal to noise ratio is in the toilet. It's noise on the center conductor of that long transmission line, part of it lying on the ground, part of it going up to the antenna. In this case, 30 feet vertical at the antenna, 15 feet vertical by the house, and the rest of it's lying on the ground. If you've ever laid a dipole on the ground, try it once. Nothing but noise. And that is what's happening. Now, as to the myth that this clamp-on makes inductance that makes a choke, remember our definitions. 50 ohms, 7 megahertz, about a microhenry. A 500 ohm choke is 219 microhenry. This clamp, any toroid, typically has one conductor going through it. That makes extremely little change in inductance. It takes multiple turns, and if you look up data for these clamp-ons, you'll find that information. But here's a short piece of 20 gauge hookup wire. On this reasonably good LCR meter, no indicated inductance. It's I don't know, 150 nanohenry, maybe 300 nanohenry. 29 inches of number 14 wire, electrical wire, is that 50 ohm figure, 1 microhenry, 29 inches. I'm going to put this mythical clamp on it and show you that there's no appreciable change. Okay, making a better contact on the wire. This is an old unit. The contacts are oxidized, the wire's a bit oxidized. That wire reads 0.7 microhenry. So barely readable. Takes a fair amount of time for it to come to that reading. Now I'll put the clamp on. With the clamp on, huge ferrite core, 1.9. So a small increase. Neither of those figures, there it's working on 2. Neither of those figures constitutes a choke, firstly. And secondly, if the antenna system is matched so that the shield does its job, it doesn't matter if there are currents going down the line. The receiver doesn't hear them because they are not going through the shield and being imposed on the center conductor. So this clamp is an utter waste. And again, if the question is stopping currents from reaching the receiver, we don't put it up here 4 inches from the antenna and leave the other 130 foot of line still connected to the receiver. We would put it here. Now, if you've seen ham radio club presentations or YouTube videos about these mythical chokes, there the inductance is ticked up to 2.1. Big deal. Wow. Now put 4 or 5 turns through there, they'll make a meaningful increase. But in these presentations, have you ever seen a test with a recorder at the receiver showing received noise like I just did, without these clamps, and then recording that while going out and applying these clamps to the feed line. You never see that. And you never see circuit analysis. What's happening here is not that the clamps do anything. What's happening is psychology and band conditions. If you listen, especially on 40, listen for an hour. You may hear propagation go up and down significantly in 5 minutes. I have heard, I've been in QSO on 40 with a station at 20 over that in a matter of 3 seconds disappeared. The propagation just died. S0, no copy. 73, can't hear you anymore, dit, goodbye. This is what's known as antenna psychology. I believe that some trivial thing that I do, from buying a $9 clamp, a trivial, easy to do thing, will make a difference. How many times do we hear make a difference in a political context? I'm going to make a difference. Go outside, drop the antenna, put these mythical clamps on, wrap them with tape, come back in 45 minutes later, and the band has died. Wow, that really reduced the noise. No, it didn't. It did nothing. The band conditions changed, and your receiver's not picking up as much noise. As I just showed you, this cannot work, and does not. It's purely myth and fantasy, invented to sell things. It sounds sophisticated and intelligent to make a complicated looking antenna system with these myriad important sounding features, like clamps to prevent common mode currents from flowing down the outside of the line. My, doesn't that sound intelligent? And I've just showed you it's pure BS. And again, if it worked, why not put it at the receiver? Well, hex bells, let's try it. 40 meters. Yaesu, just like before, same antenna, S3. See the noise level is dropping to S2. Just in a few minutes I've been doing this video. It's down to S2. Now I'm going to put the magic clamp on. Let's see what happens. Now that Ferrite doesn't have a big enough bore for me to snap it around the RG58. I'm holding it as tightly as I can. Do you see any difference? No. There, I just took it off. The noise has gone down. Ooh, ah, wow, something happened. I took my Ferrite clamp off and the noise went down, so therefore I have made up a new twist to this story, so I sound important now. And that's what's happening. This is 75 meters, 3955, top of the band. Noise level, see the peaks? That's some local noise, but it's the 40 meter antenna system badly out of tune. I've got the Ferrite pressed tightly against it, and there it's off. Did you see any difference? No, because it makes none. Now, there are people that have fallen for the myth of wrapping the coax around a toroid, and they think they've made a choke like that. Well, again, if a transmission line is continuous and matched, it makes no difference. There is an interesting thing that happens with regard to a piece of transmission line. Take 50 or 100 foot of line and lay it on the floor. Don't coil it, but just make a big U. Measure the inductance from center wire to center wire and then from shield to shield across the ends. Measure that, write it down. I have done this. Now take 10 foot of it and coil it up as tightly as you can without exceeding the minimum bend radius. Don't bend it at a 1/4 inch and kink it, but make as tight and as many turns as you can and repeat the measurement and notice what happens. Strange things happen. As I recall from when I did it, the shield inductance did not go up appreciably, but the center conductor inductance did. If you remember the inductance formula, it's wire diameter. We make higher inductance coils with smaller diameter wire, and the shield wire is huge diameter. In an RG58, that's probably the equivalent of what, a number 8, a number 7 or number 8 wire. So imagine passing a huge number 8 wire through that core. I think that's a 1/4 inch bore, so number 8 ought to fit. No inductance. Nothing happens when you clamp these things on the outside of the coax. The shield is such a huge diameter conductor, there's no inductance. If there's no inductance to start with for that short length of 1.5 inches, there's not going to be any significant change in inductance when this is clamped on. So this topic about ferrite clamps is entirely lies, myth, and BS, made up to sound important and to sell things to you. Moral of the story, don't screw with Band-Aids. Stop cutting yourself. Throw away the junk end feds, the garbage off-center feds, or OCDs as I call them. Get rid of the Mickey Mouse folded antennas, get rid of the kludges, and learn to make a proper dipole. You'll find videos on my site to do exactly that, and my antennas are flawlessly matched. And no local noise because it can't get through the cable. And I generally use good LMR 400 cable. So there you go, folks. Don't fall for the myth. KBYP.